everyone. So today we will be discussing your first topic on your finals, electricity and magnetism. Okay, I really hope that everybody is doing all right during this typhoon. Okay, so despite of this the current typhoon class, I really hope that you'll be able to continue studying. So let's discuss this one in order for you to have a continuation of your learning. Okay. Now let's have here our objectives. Explain electric charge, Coulomb's law, and electric field interactions. Solve problems involving electric forces and electric field strength. And appreciate the role of electrostatic forces in everyday technology and medical equipment. Okay, so let's have here the electric charge, forces, and fields. Under this one class, it says here that electric charge is a fundamental property of matter that causes objects to attract or repel. Take note that we have two types. We have the positive and the negative charge. If you can still remember the law of charges, we have when like charges, there are like charges, they repel. When we have opposite charges, they attract. Please take note of that. Now it says here that Coulomb's law quantifies the electric force between two charges. An electric field is the region around a charge where another charge experiences a force. Okay? So we have different legends here in order for you to understand our formula. We have F here, the electric force between two charges. Yan. Si F, siya po ay isang electric force between two charges. Take note that this is a force. That's why we're going to use the unit Newton. Okay, ano naman po si K? Si K po, it's a Coulomb's constant. Take note, if it is a constant, meron na po siyang given value. We have 9 times 10 raised to 9 Newton times square meter over Coulomb square. Okay? For our Q sub 1 and Q sub 2, it means that these are the charges in the system and these are in column or C. What is this R squared here? This R squared here, class, is the distance between the charges and it is in meter. For that is for the Coulomb's law. For the electric field naman, class, we have here E as your electric field strength. It is in Newton per coulomb. Okay, the unit is Newton per coulomb. Si K naman, class, again, ang K po natin, it's a Coulomb's constant. Ano naman po ang Q? It's a single electric charge in coulomb. Take note, magkaiba po si Q sub 1 and Q sub 2. Pag Q lang po, it's a single electric charge in coulomb. Okay, so again, itong R squared dito, class, it's the distance between the charges in meter. Okay, so we're going to use all of these formula later on in your succeeding topics or problems. So let's proceed with the sample problem. A radiologic technologist experienced a buildup of electricity while adjusting the patient's table. If the technologist accumulates an electric charge of, okay, single lang ito 3 times 10 raised to negative 6 coulomb, and a point of interest is 0.5 meters or 0.50 meters away from the charge count. Determine the electric field strength at that point. That's why we are going to use this formula because we are looking for the electric field. Okay? So take note that this one is your Q. Gamit tayo ng ibang kulay. Ayan. So this one is your Q. So what is this? Again, this is your R. And our K, class, of course, it is a constant. Excuse me. Okay, let's now substitute. We need first to convert this R squared. Ayan, dapat i-square po natin siya. 0.50, ito po. Okay, that will give us 0.25 square meter. Now, how about this one? If you're going now to substitute, class, we can have 9 times 10 raised to 9. That is your K or the constant. And then, what is this 3 times 10 raised to negative 6 here? Ito po siya. Yung ating electric charge. Okay? And then, what is this 0.25 here, class? That is your R or the distance. Now, if we are going to compute this, we can get This one, i-multiply po natin yan. Saan po ito nakuha, ma'am? Itong 1.2 times 10 raised to negative 5. Nanggaling po siya dito, class. Okay? So, dinivide po itong dalawang to and then kinapi lang po itong K natin. Okay. If you're going to compute that one in your calculator, that will give you an electric field strength at that point of 1.08 times 10 raised to 5 Newton per coulomb. Bakit Newton per coulomb, ma'am? Because we are talking about electric field. Okay, and the unit for electric field, class, is Newton per coulomb. Ayan. Now, let's have here naman, natakpan siya. Two metal plates in the high voltage section excuse me, of an X-ray machine hold charges of 2 times 10 raised to negative 6 coulomb, and the second one is 4 times 10 raised to negative 6 coulomb, and are separated by a distance of 0.20 meters. Let us now find the electric force acting between them. Okay? Why is it that we are using this? Because we are looking for the electric force, not the electric field. Okay? So, if we are going to compute that, class, let's just substitute. Ang gagawin lang po, substitute natin ang Q sub 1 and Q sub 2. Andito na po sila. Ayan. Okay, saan galing to, ma'am? This one is the constant. Saan galing tong 0.20 squared, ma'am? What do you call this one? This is the distance, okay, of the charges. That's why we're going to write it here. Ayan po siya, itong r squared natin. Okay? So, that will give you this answer. Ayan, if you are going to multiply 2 times 10 raised to negative 6 times 4 times 10 raised to negative 6, that will give us 8 times 10 raised to negative 12. Ma'am, saan galing itong 0.040? We got it from this one. Square mo lang po yan, that will give you 0.040. And then, since nakuha na po natin ang sagot dito, class, we can now multiply these things here. The K, the coulomb's constant, and the quotient between our Q sub 1 and Q sub 2 over our distance, or the r squared. So that will give us a force of 1.8 Newton. Ayan na po. Okay, how about this one? Basahin ko na lang kasi natakpan siya. A radiologic technologist touches a metal table that has accumulated a charge of negative 6 times 10 raised to negative 6 coulomb. The technologist's hand carries a charge of positive 3 times 10 raised to negative 6 coulomb. If the distance between the hand and the table surface is 0.10 meters, calculate now the electric force between them. Okay, state whether the force is attractive or repulsive. Okay, let's take a look. Take note that we already have our given here, the Q sub 1 and Q sub 2. Nandito na po sila, ito at saka ito. Now, what is our K again? That is a coulomb's constant. How about our R squared? It's the distance, okay? So, it's 0.1 or 0.10 meters, okay? Let's just substitute, class. Sabi niya dito, we have K here. We have the Q sub 1 and Q sub 2. And then we also have our R squared here. Yan, giving us an answer. We have here the conversion of our distance. And we also have here the substitution. So, minultiply lang po itong dalawang ito. That will give you 1.8 times 10 raised to negative 11 over 0.010 square meter. We are going to get the quotient of this, or i-divide po natin ito. That will give you this answer. Okay? And then, multiply na lang po natin ang ating coulomb's constant with our quotient, class. Then, that will give us 16.2 Newton. So, we can state now whether the force is attractive or repulsive. Okay? Since the charges are opposite, take note, if the charges are opposite, the force is attractive. But if the charges, class, if they are like, or if they have the same charge, class, then it will be repulsive. Magre-repel po yan. That is according to the law of charges. Okay, now let's have here another topic. Yan. Explain electrical potential, potential difference in capacitors. Describe the energy storage in capacitors. Solve problems on voltage, energy, and capacitance. Appreciate importance of potential difference in X-ray production. Now, let's have here electric potential. Potential, parang potential energy. It is the electrical potential energy class per unit charge. Take note that the voltage drive charges in circuits. Please take note of that. And we have here a formula. We have V is equal to W over Q. Ano ibig sabihin ng V? That is your electric potential charge or what we all know as the voltage or the volt. Yan. V po yan. Ano naman po ang W? Of course, it's the work done on charge in joule. Take note, pag work, it is in joule. How about this Q here? This is the electric charge in coulomb. Okay, please take note of the units class. Now let's have a sample problem. A radiology room cable moves a charge of 0.02 coulomb using 1000 joule of energy. Calculate the voltage across the table. So we are looking now for the voltage. That is why we are just going to use V is equal to, or the volt is equal to the work done on charge over the electric charge. Okay? Substituting this, ano ba itong 0.02 dito, class? That is your Q. Okay. Ano naman itong 1000 joule, ma'am? Of course, that is your W since it's your joule. Okay? And now, we can now substitute 1000 is our W and 0.02 coulomb is our Q. Okay, giving us the answer of 50,000 volts. Take note that in 1 kilovolt, we have 1,000 volt. Okay, please take note of this, that in 1 kilovolt, we have 1,000 volts. So if we are going to convert this 50,000 volt class, of course, we have 50,000, excuse me, 50,000 volt times in one, what is our unit here? It's in volt. What is the value of volt here? It's in 1,000. What is the equivalent of 1,000 volt in kilovolt? Of course, we have 1 kilovolt. Canceling volt now, volt. That will give us the answer of the voltage across the cable is also in 50 kilovolts. Tama po ba ang sagot natin? If we are going to divide 50,000 to 1,000 class, that will give us 50 kilovolts. Okay, I really hope that we are clear with this. Now let's proceed to our electric potential. A capacitor stores charge and energy. Capacitor naman po ang pag-uusapan natin. Okay, so we have C, or the capacitance in farad. Take note that our C here, it's not coulomb, it's capacitance. And then our Q is the stored charge in coulomb. Take note that our Q is in coulomb, the stored charge. And our V, of course, is our electric potential or our voltage in volts. Ayan. Let's have an example problem. A capacitor stores 0.01 coulomb. Okay, take note that this 0.01 coulomb class, it's not an electric charge. It is a stored charge kasi stores, nag-store po siya. That is why this is your Q. Right? At 50 kilovolts. Kilovolts, that is our V now. Ayan. So, substituting these things, class, we have 0.01 coulomb and we have 50 kilovolts. Take note that if we are going to have 50 kilovolts, we have 50 kilovolts times how many kilovolts do we have in how many volts do we have in 1 kilovolt? We have 1,000 volts. Okay? So canceling kilovolts, that will give us 50,000 volts. Okay? That is why 50,000 po ang nandito. Okay? Because we converted kilovolts to volts. Ayan. And then, if we are going to divide these things here, class, that will give us 2 times 10 raised to negative 7 farad. Okay, bakit farad, class? We are looking for the capacitance and our capacitance must be in farad. Okay? Now, let's move on to the next one. Sabi niya dito, um, an imaging plate used in a digital radiography system must be charged before use. Charge daw siya. The plate requires a total charge of 5 microcoulomb. When a potential difference of 5 kilovolts is applied, determine the capacitance of the imaging plate. Paano naman to i-compute? Ayan. Take note that our charge in, what do you call this one? In, or the charge or Q is in microcoulomb. And take note, class, that if we have in what they call this one, one coulomb, class, one coulomb to microcoulomb, class, microcoulomb is equal to, wait lang, check lang natin. Okay. So, 1 coulomb naman dito, class, kung ang kilovolt, 1 kilovolt is equal to 1,000 volt. Ang 1 microcoulomb naman, class, ang 1 coulomb, sabi ko sana, okay, it's 1 coulomb is equal to 1, I think this one is 1 million. Yeah. 1 million. 1 million microcoulomb. Yeah, it's 1 million microcoulomb. So if we have 5 microcoulomb times, how many microcoulomb do we have here? Sabi niya dyan, we have 1 million. 1 million microcoulomb. Microcoulomb. And anong equivalent niya is it's in 1 coulomb. Canceling microcoulomb, divide lang po natin ang 5 microcoulomb divided by 1 million. That will give us 5 times 10 raised to negative 3 coulomb. Or if we're going to expand this, class, this one is 5. Ayan, gagawa tayo na 1, 2, 3. Okay, 0, 0, 0.005 coulomb, or we have 5 times 10 raised to negative 3 coulomb. Okay? Ayan. Now, let's move on to the voltage. Take note that in 1 volt, we have 5 kilovolts here. 5 kilovolts times how many kilovolt do we have? What is the value of kilovolt in our conversion? It is 1. How many volts? What is the equivalent of 1 kilovolt in volt? That will give us 1,000. Okay? So, canceling kilovolt, 5 times 1,000 will give us 5,000. 5,000 or the 5 times 10 raised to 3. Try natin. Okay? Dagdag lang tayo na, try natin to 1, 2, and 3. Okay? So, we have 5,000. 5,000 volts. Tama po ba? Yan. Okay? We can now substitute them. Okay, we have 5 times 10 raised to negative 3 divided by 5 times 10 raised to 3. That will give us 1 times 10 raised to negative 6 farad. Okay, because that is in coulomb. Now, let's move on to our electric potential, which is energy in stored. Okay, we have now U, energy in stored in a capacitor naman tayo. Okay, kanina we have stored charge. Ngayon naman, we are going to use energy stored in a capacitor. Take note that capacitors stabilize power supply in extra generators and digital processors. Okay, so let's have here our formula. Our U is energy stored in a capacitor, and then that is energy in class. That is why it is in joule. 1/2 here is a constant. Nandyan na po yan, class, or given na siya. 1/2 times our C. What is our C, class? It's not coulomb, but it is in the capacitance in farad. And our V here is our electric potential charge, or the electric potential, or the voltage in volt. Okay, so let's try an example here. A portable X-ray machine uses a high voltage capacitor as of its power supply. The capacitor here, class, the capacitor has a capacitance of 10 microfarad and is charged to 20 kilovolts before each exposure. Determine now the amount of electrical energy stored in the capacitor. Take note, class, it must be in farad. Okay? Take note, class, that 1 microfarad is equal to 1 million farad. Tandaan po natin. 1 microfarad is equal to 1 million, 1 million farad. Okay? So we have 10 microfarad here, 10 microfarad. Convert it into farad. Ilan ang equivalent ng microfarad ilan ang value ng microfarad natin dito sa taas? It's 1. Okay? So, ilan ang equivalent niya into farad? It's in 1 million or 10 raised to 6 farad. Canceling 10 microfarad, this microfarad here dito sa kabila at dito rin sa denominator natin, that will leave us a farad. That will give us a farad unit. Okay, multiplying 10 microfarad, 10 now to 1 million, that will give us, okay, ilan po ba magiging 10, that will give us a 10, okay, wait lang, check natin, baka mamaya magkamali ako. Oh, okay. Wait lang, baka mamaya magkamali ako. Okay, baliktad. Baliktad, sorry class. Ang ating 1, okay, baliktad po. I'm so sorry for that. We have 1 farad. 1 farad is equal to 1 million. 1 million microfarad. Okay, baliktad po siya. I'm so sorry for that. Okay. So, if you're going to convert 10 microfarad here, 10 microfarad times, ilan ang microfarad natin dito, class? That is, our microfarad is 1 million. Okay, so if it is 1 million, we have here 1 farad, canceling microfarad, 10 divided by 1 million will give us 10 times 10 raised to negative 6. Okay, that is for our capacitance in farad. Now, how about our kilovolts here? Of course, this kilovolts here must be converted into volts in order for us to proceed with the substitution na 2,000. Okay, 20 kilovolts times, this is in kilovolts. Okay, we have 1 kilovolt is equal to 1,000 volts. Take note that 1 kilovolt is always equal to 1,000. 1,000 volts. Canceling kilovolts, kilovolts will give us 20 times 1,000. That will give us 20,000. Okay, squared pa po natin yan, class. That will give us dalawang beses po natin is i-multiply si 20,000 sa kanyang sarili, or multiply lang po natin si 20,000 sa kanyang sarili, class. Okay? So, if we can now get his the answer, if we are going to multiply 0.5 times 10 raised to 10 times 10 raised to negative 6, and then we can also have 20,000 here. Okay? And so that will give us the energy stored in a capacitor in joule is 2000. Okay, now let's have here our clinical relevance. Capacitors help regulate voltage for X-ray tube exposures. Electric potential determines electron acceleration in tubes. Ayan, let's have our last topic. We are going to define current, resistance, and the Ohm's law. Okay, so these three things, they used to come sabay sila or lahat sila madidiscuss when it comes to electricity in and magnetism. Okay? Identify factors affecting resistance, calculate current, voltage, and resistance, value electrical safety during imaging procedures. Okay, now let's have here, what is a current? Ang current po natin is the flow of charge per time. And we are given with the formula I is equal to Q over T. So when we say I class, I is our electric current in ampere, ang ating unit. And our Q is the electric charge in coulomb. And T is our time in seconds. Okay? Let's have a sample problem. It says there that in an X-ray tube, a total charge of 0.5 coulomb flows through the filament in 0.25 seconds. Calculate the filament current. Ibig sabihin, we are going to use this formula without deriving the formula since we are looking for the current. Okay? So let's have here, we have the given 0.5 coulombs, the charge, the time is 0.25 seconds. Okay, let's substitute class. 0.5 is our Q or 0.5 coulomb, the electric charge. Our time is 0.25. We're going to get the quotient of that. Divide lang po natin sila. That will give us 2 ampere. Okay? Take note that in current, we are going to use ampere. Okay? So, the filament current is 2 ampere. How about resistance? Tandaan po natin, kailangan po natin ng resistance para hindi po dire-diretso ang pag-flow ng kuryente. Kasi hindi po pwede yun. Okay? So, resistance opposes the current. Okay, we are given with, excuse me, okay, with the formula, the volts is equal to I times R. Okay, so if we are going to look for the resistance class, divide lang po natin yan if we are looking for the resistance. Okay, we need to derive a formula from the general formula which is V is equal to I times R. Anong nawawala? Example is si R. Okay, si R ang nawawala, bring down lang po natin si I. Si I dito, cancelling I. R now is equal to V over I. Okay, take note that V is the voltage, our I is the current in ampere, and the resistance is in ohm. Okay, now let's have here. Tama ba yung formula natin? Yes. A protective equipment heater operates at a voltage of 120 volts and draws a current of 5 ampere. Calculate the resistance of the heater. Okay, take note that this 120 volts is your volts, and this 5 ampere here is our I. If you're going to substitute it, class, mabilis na lang siya. Yan na po yung given, 120 divided by 5, that will give you 24 ohms. Okay, that is now your resistance. The resistance of the heater is 24 ohms. Okay, I have here an activity. You may pause our video lecture and try to answer this one. A cable in fluoroscopy unit experiences a voltage drop of 60 volts when a current of 3 ampere flows through it. Calculate the resistance of the cable. Ayan. So we have 60 volts and 3 ampere. Just substitute it and that will give you 20 ohms, or that is now your resistance. And the resistance of the cable is 20 ohms. Now, another activity in the detector electronics of radiology unit, a current of excuse me, 0.02 ampere flows through a resistance of 500 ohms. Calculate now the voltage across the resistor. Ayan. So, since this is the general formula class, we're just going to substitute now I. Our I, or current, is 0.02 ampere. And our resistance is 500 ohms. If we're going to multiply them, that will give us 10 volts. Okay, so the voltage across the resistor is 10 volts. And so these are the factors that affects the different variables. We have the length, the thickness, the material, and the temperature. So in radiology class, filament current controls the electron production for X-ray tubes. And another clinical relevance, current heats the filament to release electrons. So if there is a heat, if the temperature is high, the filament class will then now release electrons. And resistance helps regulate tube currents and prevent overloads. Okay, take note that resistance prevents overload. Kasi pag magkaroon po ng overload class, pwede mag-spark or magkakaroon po ng short circuit. Okay? That's why we need resistance. Okay? Parang sa totoong buhay lang po yan, kailangan natin i-resist ang mga temptations in order for us not to be in trouble. Okay? I think that is the last topic that I'm going to discuss today. So, next meeting, we will be discussing your next topics under electricity and magnetism. So, thank you so much, everyone. I really hope that we are all safe. God bless.